We're going to start this section with a very important historical result, which is what's called the fundamental theorem of algebra. So what that states is that if you have a polynomial, right, and the degree is at least 1, then you know it has at least one zero. Now, the way they phrase it is at least one complex zero. So I'm going to kind of put that in parentheses. I want you guys to remember that any number ever counts as a complex number, right? So we typically think about things like 2 plus 3i, or 5 minus I. Those are more obviously complex numbers, but remember, any kind of number, like 2, or 7, or -3, or 0, any kind of number counts as a complex number. So when they're telling us there's at least one complex zero, really they're just saying there's at least one zero of some variety. Maybe it's real, maybe it's non-real, but there is a zero out there. So as soon as someone was able to prove this, someone took it a step further and said, okay, well, if we have a polynomial and we know the degree, then in fact, we don't just know there's one zero, we know exactly how many zeros there are. So if the degree is n, the number of zeros is n. And again, that word complex is kind of optional here. Now, something that makes this a little bit complicated is the fact that some of those zeros might be repeated. So I want you to think about kind of a typical example that we might have solved before learning this fact. Let's do x squared minus 4x plus 4 equals 0. That'll be a good one. Okay, if I were to solve this, I would factor it as x minus 2 times x minus 2. And if I set each factor equal to 0, okay, what we would find is that I'm only coming up with one unique solution, and that's x equals 2. So if I looked at this polynomial at the beginning and said the degree is 2, so I expect there to be 2 roots, or 2 zeros, we're considering the fact that if a 0 shows up more than once, we count it more than once. So even though there's only one unique number here, that's x equals 2, because it showed up multiple times, or in other words, in multiple factors, we're going to count it twice. Okay, so we have the caveat on this statement that, yes, the degree tells you how many roots they are, but that includes maybe some of them being counted multiple times if they show up multiple times in the factorization. Now, another bonus fact we get with this is anytime we have a non-real root, or you could say a non-real zero, so something like 2 plus 3i or 5 minus I, then we also know immediately another zero of that function, which is the complex conjugate of that guy. So for example, if 2 plus 3i was a root, I would immediately know that 2 minus 3i is also a root, right? Or if someone told me that 5 minus I is a root, I would also know that 5 plus I is a root. Again, root, zero, x-intercept, those words all mean the same thing. Okay, so this gives us tons of information. As soon as I see the degree of a polynomial, I know lots of facts about it. So just as kind of a quick example, someone might ask me, how many complex zeros does this function have? Well, the only thing I need to decide is what's the degree? Well, in this case, the degree, or that biggest exponent of x, is 5. So the number of zeros is 5. And maybe some of those are real and some are non-real. Maybe some of those are repeated. I don't know. All I know is that in total there's going to be 5 zeros.